Okay, so in the previous video, we looked at the divisibility checks for all of these different numbers. Now, this isn't explicitly in the GCSE, it's kind of pre-GCSE, but the 7 and the 11 isn't something you need to explicitly know about. So I just wanted to put it in as like a nice little pre-part of this topic. So it says, without using division, check if 491,909 is divisible by 11. So we're going to do that same thing that we did before. We're going to look at the odd position digits and the even position digits. So we're going to look at the odd and even position digits. Now remember, it goes first, second, third, we're counting backwards, fourth, fifth, and that 4 is the 6th. So the odd ones, which I think on the previous page I did in blue, is the first, the third, and the 5th. And I'm going to sum those together, so we get the 9 plus the 9 plus the 9, which is 27. Now I'm going to have a look at the evens, which I think I did in green. So the even ones are in position 2, 4, and 6. And I'm going to sum those together, which is the 4 plus the 1 plus the 0, which is 5. And the rule is you take the sum of the odd, you subtract the sum of the even, and we see if it's divisible by 11. It is divisible by 11, so that means that overall 491,909 is divisible by 11. Now, other numbers that you could have got something like 11, you could have got 0, you could even get minus 11. All of these things would show that something is divisible by 11, because this is 11 times 2, 1, 0, and minus 1. So these numbers that I've put down here, if you got any of those results, they would also show that something was divisible by 11. So let's have a quick look about doing the division with these numbers to see if we can use the divisibility check of something being divisible by 7. So I'm going to start off by doing my 3,561. The rule says you take the last digit, this is my rules that I've got up here, when you double the last digit and subtract from the remaining number, the result is divisible by 7. That's what it would be. So when you double the last digit and subtract from the remaining number, now my remaining number would be 356, and I would subtract double 1, which would give me 354. I'm going to have to repeat that process with the 354. I'm going to double the last digit and I'm going to subtract it from the remaining number. So my remaining number is 35. And I'm going to be subtracting 8 from that. So I'm going to do 35 take away 8. So that is going to be 27. Now 27 is not divisible by 7. So this means that 3561 is not divisible by 7. So I'm just going to very quickly show you that on my calculator. 3,561, if I divide by 7, I get a fraction or a decimal term, so it is not divisible by 7. The previous question, I should have shown you, 491,909 divided by 11, it is divisible because you get an integer answer. So that was part A of the question. Let's try part B, which is the number 2,667. So I'm going to double the last digit, and I'm going to subtract it from the remaining number. So that's 266. And I'm going to subtract double 7, which is 14. 6 take away 4 is 2, 6 take away 1 is 5, and then I still have the 252. So I've got 252. I'm going to double the last digit, and I'm going to subtract it from the remaining number. So that's 25, and I'm going to double the 2, so I'm going to subtract 4. 25 take away 4 is 21. 21 is divisible by 7, so this means that 2,667 is divisible by 7. Let's just show you that on the calculator. 2,667 divided by 7 gives you 381. So you can make up some of your own numbers for this to see if you want to check some divisibility things, but it's a neat little thing that might help you if you're trying to figure out for some of the parts in this later topic what things might be divisible by. Okay, in the next video, we're going to look at prime factorization, and this is definitely in the GCSE, so the previous videos will help you with this. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.